Hello and welcome to the Tuesday, May 27th, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, and this episode brought to you by the SANS.edu Master's Degree Program in Information Security Engineering is recorded in Jacksonville, Florida. Well, today's diary was a little bit inspired by a YouTube comment stating that, you have problems doing steganography in a lot of these sort of pixel bitmap-based image formats because they're often then compressed. And as a result, some of the detail is lost that you're usually after when you're doing steganography. So, for example, in particular with formats like JPEG, for example, you have various compression levels, and sometimes even on download, for example, mobile ISPs famously often do that, where if they're able to intercept the bit stream, are then able to further compress images, losing some of the detail. An alternative to these bitmap-based formats is SVG. Now, SVG as an image format is very popular on the web. On our website, for example, a lot of the icons use SVG because SVG is an XML-based format and easily embedded as part of HTML. And being vector-based, of course, usually no compression happens, and also they nicely scale with the size of the image. And what you can do with SVG is not just create little icons and line-based drawings, but you can convert some of the bitmap-based images to SVG. And what you end up with then is basically areas in the image that have a certain color, and that color can then be adjusted just the same way it has been done with pixel-based images. Well, that's sort of what's at least commonly done these days with SVG, where the colors are just slightly shifted. Basically the same algorithm that is being used for pixel-based images, but with vector-based images, you actually have additional options. So, for example, if you do have a particular line in the image, you could split that line into two. And as long as these two lines line up with each other, there is no real visible change to the image. And then, for example, you could encode values in the ratio between these two parts of the line. Since the coordinates here are float, they're not integer. Remember, we are not dealing with pixels here with these images, but more with distances and such, and everything is supposed to be easily scalable. So in that case, we can actually, even for a short line, still sort of have the full float address space here in order to encode data in this line. The image would become larger, and of course the one attractive part of SVG is that for little line drawings they're very compact, but certainly something that wouldn't necessarily be noticed unless you specifically look for it, and a recipient or someone who is decoding the image doesn't even need a special key or so that you often need in order to decode some of the more traditional steganography methods. Of course, you could still add something like this, but I would rather recommend, if you actually want some form of encryption, just encrypt the data before you encode it in the image. So just something a little bit to play with. As I mentioned in the diary, I may actually publish a little proof of concept tool implementing this kind of steganography later in the week, but depends on what else is coming up. And about a week ago, on May 13th, Fortinet published an update for a number of its products fixing an already exploited buffer overflow vulnerability. This particular vulnerability does allow full access to the system remote code execution without the need to authenticate. Well, we now got a write-up from Horizon 3.ai telling us a little bit more about how this particular vulnerability works and how to write an exploit for it. The problem here, turns out, is related to the authentication cookie. It's an ASP cookie, or APS cookie, that's what they call it here. And this particular cookie, when it's decrypted, then, well, the buffer overflow may be triggered. Also interesting, they're not just sort of walking us through how this particular cookie works, but also through how they use GitHub Copilot with GHydra in order to actually find the vulnerability and then being able to exploit it. And we got an interesting new attack against, well, AI code assistants. Of course, there have been a number of similar papers, blog posts, and attack proposals. This one comes from Legit Security, and I think is, well, pretty legit, but also a little bit new and interesting in the way it works. It particularly targets the GitLab Duo AI assistant. Now, the basic problem here is that as part of your source code, you may add comments that are then directed at GitLab Duo, and they essentially, well, are commands that you want GitLab Duo to execute, or, well, that's basically here where the prompt injection happens. This will now modify how a victim who is, for example, approving a pull request or so views the code. These can be encoded using Unicode and such to make them invisible. One trick they, for example, demonstrated is where you tell GitLab Duo to include a link and then entice the user into clicking on the link by giving it an unsuspecting label like that. You find more details about the pull request, this particular URL, but the URL itself, for example, may then include source code or secrets that GitLab has access to. Interesting attack, and yep, yet something else to be aware of if you're using these type of assistants. Well, that's it for today. Thanks for listening. There was no podcast on Monday because it was Memorial Day here in the US. Forgot to announce that on Friday, so sorry for that. And, well, talk to you again tomorrow. Bye.